In this tutorial, we're going to learn how to answer questions that ask us to evaluate a function, and they are providing us with the value that we use to substitute into the equation which is given to us in function notation. So what does all that mean? Well, let's just take a look here. We have two functions listed above, and these functions are listed in function notation. We have f at x, which is clearly a linear function, and we also have g at x, which is a quadratic. Well, if the question asked us to evaluate and then said, what I want you to evaluate is f at 4, how would we solve that? Well, it's a simple matter of substitution. All we're going to do is we're going to recognize that this variable that's listed here is also listed on the right side here. And when we are given questions asking us to substitute in a specific value for x, well, then all we do is we go ahead and we substitute it in place of the x on the right side. It's asking us, can you please evaluate the function when you use 4 instead of x? So all I'm going to do here to evaluate this is I'm going to take and substitute 4, and I'm going to use brackets, it's a good practice, in place of the x. The rest of the equation will remain exactly the same, and it will become negative 5 times 4 plus 3. Well, following our order of operations, we know that this is going to work out to be negative 20 plus 3, and finally negative 17, which means that the value of this function, when I substitute in 4 for x, is negative 17. And a little more about what that means when we finish working with the g at x function. All right, let's take a look at g at negative 3. How do we solve this? Again, we are given the variable here that appears on this side as well. So when we are asked to substitute in a value for x, in this case negative 3, I'm just going to go over to the right side and I'm going to write a negative 3 in place of the x. The rest of the equation is going to stay exactly the same. It will be negative 3 times the value of x, negative 3 minus 1 squared plus 2. We'll just follow along with order of operations. We'll focus inside the brackets first. Well, negative 3 minus 1 is negative 4, and that's still squared. I know that negative 4 squared is positive 16. I know that 3 times 16 is 48. And if I add 2 to that, I'm left with 50, which means that the value of the function g when I substitute in negative 3 for x is equal to 50. So there's the two answers. Well, just to give you an understanding of what this means, let's take a look at first the linear function. And we had f at 4 equals negative 17. What does that mean? Well, let's just do a quick little sketch here of this function. And we'll label our x and y axes. Well, we were told that the original function was negative 5x plus 3. And this plus 3 here, well, that is our y-intercept. We also know that we have a slope of negative 5, and that is down 5 and over 1 each time it steps. So if I was to put a fairly steep slope on this, so down 5 and over 1, it might appear as such. Okay, so what does this f at 4 equals negative 17 actually mean? Well, what it means is that when x holds the value of 4, to be on this line, on this function, you will be at negative 17, the y value. And that is what f at x means, is solve the y value when you substitute in x is 4. Okay? Well, what about the quadratic we have here? Does the same principle apply? And it certainly does. If I was to draw a quick little sketch, and we've got our x and y axes here, well, we know that this quadratic here has a vertex at positive 1 and positive 2. So if I was to go over 1 and 2, it would be right there. It opens up, and we can see that the stepping pattern has been altered. It's been vertically stretched by a factor of 3. So this is going to be pretty narrow, and it's going to go through there and then scoot up. Now, this says that the function g at -3 is equal to 50. And all that means is that if we were over here at, and I'll just change the color here so you can see, at -3, well, we would be way up here, and when we go over in the y-axis, it would be 50. So we're way up on that left arm, quite high on the parabola. Okay? So hopefully that clears things up. When we're asked for the value of a function, and we are provided with the value to substitute in, all you're doing, substitute whatever's in the brackets into the equation, simplify it, and get an answer.